Good evening, everyone. Welcome to the week 9 of course Wastewater Treatment and Recycling. The course instructor of this subject is Professor Manoj Kumar Tiwari from IIT Kanpur, and my name is Manetnam Prakash, and I am also a PhD student um, at IIT Kanpur in environmental engineering. So we meet every Tuesday on this timing, that is 7 a.m. to 9 p.m. 7 p.m. to 9 p.m. via Google Meet. The link for which has been already shared with you. And similarly, the recording of this session are being uploaded on this YouTube channel. That is the link for which also has been shared with you. Okay. So in week 9, we will be discussing the tertiary, that is advanced treatment of wastewater. So till now, if you recall all the previous lectures, first we started with the basic wastewater, then we went for the preliminary treatment, then we went for primary treatment, then secondary treatment, that is biological treatment, and finally we are to the advanced level that we want to reuse that water. So we have to make that water fit for, suppose our reuse purpose is of drinking, then we must ensure that the treated water meet drinking water quality. So if you recall drinking water parameter is the limit which has been set in India, the limit, the authority which is all the limits are given in IS code IS 10500 2012. So in there you will find the limit of each and every water quality parameter. So each and every water quality parameter and the standard should meet those values. What the treated water should meet those standard value. In that way only, then that can be drinkable. There can be other reuse purpose. Maybe suppose I am reusing for irrigational purpose. Then for that also we should know that what is the criteria. Means if we are reusing for this thing, what do we call irrigational purpose, then we should be sure that how those water miss for irrigational purpose, what kind of water is needed. So that limit is also set by some generally it is set by CPCB, pollution control board. So and I might be wrong also, but pollution control board generally said that if you are discharging in river land, so I have to see for discharge in soil, that is for reuse purpose, who set the rules. Okay now. So there we should control, there is requirement that this much should be nutritions, because we know that the nutritions are generally high in organic and sorry, phosphorus and nitrogen, that may lead to production of Lg. So we don't want Lg in our system. Okay, so the nutrition should be removed, Then we know that there might be some heavy metals. Suppose if you recall my previous discussion, I was discussing about chromium industry, that is leather industry, where they use chromium. So the chromium should be removed. So the chromium can be removed by several mechanism, and generally chromium is removed by this method, that is precipitation. That is not listed here, but suppose arsenic is there. So arsenic is generally removed by adsorption. Uh, hmm. So arsenic is generally removed by adsorption, and similarly there can be some other element also which can be removed by ion exchange. So that also come under this tertiary treatment. Hello, I did not see your name. Ruchita Sahu, welcome to the session. So I'm just giving the brief introduction, like what we are going to discuss in the upcoming lectures. Then there is called membrane process. So everyone is familiar with this membrane process. So we will be discussing some of the membrane process that are involved in tertiary treatment of wastewater. Disinfection and chemical treatments. Uh, hmm. So disinfection all whenever when suppose we are when we I'm talking about disinfection, then generally in our mind comes that we are disinfecting, that we are reusing for drinking purpose. There might be other purpose also, but I am mainly focused on if we are doing advanced, means we are wasting money for advanced treatment process. Okay, now then in that case, and someone is there. Hmm. So in that process, we will be using chlorine. We will be using chlorine or ozone and all these things. So I will be discussing it one by one. And chemical treatments, again, I will be taking example of chromium, where we treat by chemical by adding some chemical in the form of iron. So generally chromium is reduced. Chromium 6 is reduced to chromium 3 with the help of this iron 2, and iron 2 get oxidized to Fe3, and both of them form a precipitate, and they can be taken out from the system, and we will be getting. So I will be looking at these topics one by one. Okay. So this is the overall scenario. We have already discussed about this treatment. We have discussed about primary treatment, we have discussed about secondary treatment, and then finally we are here at this advanced treatment, that is. And you can see that water is coming after miss. Here we have already removed the larger particle, here inorganic particle, here biological, that is organic matter. And we have already also discussed about the sludge process. So here the water which is coming is free of those materials. Here there might be some nitrogen, phosphorus. Then finally we will be removing some dissolved solid, maybe high calcium is there, high sodium is there. So we know that there is some limit of calcium, magnesium, so that should be removed. So we'll be looking into those things only. So coming to the basic things, basic definition, that what is tertiary advanced treatment of wastewater. Tertiary treatment is the final stage of wastewater treatment that focus on the further polishing the water after primary and secondary treatment process. So we have already discussed this, that we will be polishing means, I hope you all are understanding what is this polishing. Polishing means final. We are just now at the verge of releasing the water into open channel or open field, anything. The main goal of the primary treatment is to remove the remaining suspended, whatever remaining suspended solid there, any dissolved organic compound is there like nitrogen and phosphorus and any other pollutant, to make the water safe for reuse or discharge. Remember, reuse can be anything. Reuse is like reuse. I have already reuse in agricultural field, reuse for drinking, and then finally discharge into sensitive environment like rivers or lake. So finally we will be discharging into river. That is the that can be also a secondary. And for that we know that there is some limit. If we are discharging our water in river, so there is some limit that this much this much should be the value of do organic matter, nitrogen and phosphorus, so that should be met. So depending upon that, so this is overall definition of tertiary treatment. So main I'm just focusing on main process involved in tertiary treatment. Is first is filtration. Okay, so filtration is advanced filtration techniques like sand filtration or membrane filtration are used to remove any remaining suspended particles. Okay, then second is disinfection. That means any suspended solid particles, suppose after or there are high chances we have removed most of the organic particles in our primary sedimentation, but still there are chances that there will be some suspended solid in our treated water. So we will be using filtration unit like this slow sand. So there will be a layer of sand and some arrangements are there. Water is passed through it, and the water which we get at the end of our tunnel, end of the our section, is water free from any suspended solid. Then now this is the we have disinfection. This aims to kill or inactivate pathogens before discharge. Common disinfectant method includes chlorination. That we will be using now. We know that there will be some kind of pathogens also. Remember in mpn we have seen that when we were discussing about coliform and all these things, so we need to kill those pathogens, because that might cause any kind of mm, that might cause waterborne disease. So generally we use chlorine. Okay na, so with the help of chlorine the pathogens are killed. Then we have ozonation, use of ozone. Okay, then we can also kill the bacteria or inactive pathogens with the help of uv radiation. Okay, ultraviolet radiation. Finally we have nutrient removal. A special process are used to remove nutrients, especially nitrogen and phosphorus, which can be due to eutrophication, because we know that this for alga means for algae growth, nitrogen and phosphorus are food for them. So that's why we need to make sure that those are being removed. Okay, then for that we have nitrogen removal achieved through biological process like nitrification and denitrification or chemical methods. So generally some kind of bacteria are used, that is known as nitrifying bacteria, denitrification bacteria, and all those are nitrogens are removed. Miss, miss, what is this process of nitrification and denitrification? You can always check on some standard book. Okay, then we have phosphorus removal using some chemical precipitation, adding alum or so what happened that when we add alum in the system, phosphorus precipitate in the form of a some kind of some kind of salt and all this thing, and we have we we are able to achieve our target. Okay, then another thing is that activated carbon adsorption, so use of remove trace organic matter. So for to remove the organic matter, what we do that we use activated carbon. So what happens that this organic matter can get adsorbed on this activated carbon. Okay na, color order from the water by adsorbing them onto activated carbon. So generally when organic compounds are present, there might be some odor or color due to that, so we can remove with the help of activated carbon. Okay, then we have advanced oxidation process. These are chemically process that involve the generation highly inactive oxygen like hydroxyl radical to degrade organic pollutant, common include ozonation and UV or peroxide H2O2. Okay na. So we can also have this advanced oxidation process. We will be discussing what is this advanced oxidation process and all this thing. Okay, so what happened that with the help of this hydroxyl, that is OH dot OH. Okay, So this is highly reactive. So this will degrade our organic matter in a at a higher rate. Okay. So coming to the next slide. Before going for more discussion, I just want to have a numerical problem. Uh, have a numerical problem on the miss related to previous discussion. So this question is very simple. That just you have to multiply few things, okay, na? And you have to find some concentration of the thing. A wastewater treatment plant has an influent of means this much meter cube of water is coming per day. The effluent from the secondary consists this much of phosphorus. Okay, the plants needs to phosphorus concentration to 1 milligram. So initially this much is coming out and this much is going out, and you have to remove this thing. Okay, generally this kind of question you can expect. Okay, calculate the mass of aluminium required per day if 1 mole of aluminium precipitate 1 mole of phosphorus. So this question is very easy because they have already given you that this alum is added and this much amount of alum is precipitating this much amount of phosphorus. The difficult part would be that one should know the proper reaction between Al2SO4 Al2SO4 and this phosphorus. Generally phosphorus will be present in the form of PO4. Okay now, so you have to write your reaction in a such a way that this PO4 and this you have to write reaction in pH dependent form. So here they have not done any kind of things, but they have directly given you the question. So this is good. Okay now. So this is good. So I will be solving it. So the influence of the phosphorus is this much. That is, so you have to find how much aluminum sulfate has to be required. So this you can see that initial phosphate concentration is this much. Finally, this much. So the phosphorus removed to be 14 milligram per liter. Okay now. The volume of water treated per day is this much cube. So mass of the phosphorus to be removed this milligram per liter into, and I am converting meter cube into liter. That is by multiplying into 10 cube over 3. This liter will get cancelled out, and we will have this much milligram per day of phosphorus, or this much kg per day of phosphorus. Okay, na. So in question it is already given that we know that the molar mass of this phosphorus is 31 gram per liter. So the mole of phosphorus will be this much divided by 31, that is 4516 mole per day. And the question itself written that 1 mole of phosphate react with 1 mole of aluminum. So and molar mass of aluminum is 342. Aluminum sulfate is 342 gram per mole. So therefore the aluminum required will be this into the. Hmm. So I'd say you can see that the mass of aluminum required will be this much gram. Okay, na, this much mole. This much mole of aluminum is also required. So we can calculate the mass by simply multiplying this. This mole and mole will get cancelled out. So this much kg of aluminum sulfate, that is 1544.47 kg per day of aluminum sulfate is required. Okay, na. So here we have seen the treatment plant need approximately this gram of kg sulfate per day to remove the required amount of phosphorus. Okay. So coming to the most important part, that is nutrient removal. So first you should know what is this nutrient and why we are removing the nutrient. You should be able to answer those things. So nutrient removal is a critical component of tertiary advanced treatment in wastewater management, primarily aimed at reducing nitrogen and phosphorus level. Excessive nutrients in the water bodies can lead to eutrophication. Okay, now. So that's why you should know that. And what is eutrophication? That is growth of algae, causing harmful algae blooms, oxygen depletion, and effect on some determined mental effect on wastewater and effect on aquatic life. So, so what will happen that once uh, due to presence of nitrogen and phosphorus, once these alga had grown in the river or lake, so what it will do that it will start consuming all the dissolved oxygen. And we know that a minimum of 4 gram per liter dissolved 4 milligram per liter uh, dissolved oxygen should be there to for aquatic life to survive. So once we don't want that, so that's why there should be control on nitrogen and phosphorus release in lake or river. So the key process for the removal are the first and the most conventional method is nitrification. Okay, now so this biological process uh, this biological process involves converting ammonia, that is NH3, to nitrate. Okay, and this is done with the help of some kind of bacteria that is known as nitrifying bacteria, that is nitrosomus or yeah, nitrosomus and nitrobacter. This typically occurs in two steps, that is ammonia oxidation to nitrate and finally nitrate oxidation to nitrite oxidation to nitrate. Okay, now then we have denitrification, that is in anaerobic process, that is in absence of oxygen. Denitrifying bacteria, that is pseudomonas, convert nitrate that has been formed here to nitrogen gas, which is released into atmosphere. Okay, now so this process required a carbon source which can be provided by adding organic matter or using endogenous carbon from the treatment process. Welcome whoever joined the session. If you have any kind of doubt, you can ask. So I was just discussing about this tertiary treatment. Okay. So generally, in all the treatment plant, generally this method of nitrification is followed for removal of nitrogen. Coming to the this phosphorus removal, generally phosphorus are removed via chemical precipitation only, because biological uptake it has been observed in several treatment plant or several research also that biological uptake is very low. So generally people at several treatment plant prefer chemical precipitation, and the uh, most common element, yeah, chemical that has been used and are being used currently is aluminum sulfate. So but at several places this aluminum sulfate has been stopped, because in the process of removal of phosphorus, it has been observed that aluminum also releases dissolve in the water, and the treated water sometimes contains high amount of aluminum, and this aluminum is very toxic to humans, that can cause some kind of neurological problem like dementia and all these things. Then ferric chloride is also used. Lime are also reacted with phosphorus, forming insoluble precipitate. Example, aluminum phosphate, that can be removed by sedimentation. Okay. So and another process is biological uptake, but generally these biological update are not followed, not taken, because this is not economically viable option to treat, because we know that we have around lakhs liter of water. So certain microorganisms can uptake phosphorus during their growth, enhance biological process removal, employ a specific condition to promote the growth of polyphosphate accumulating organism, which stores excess phosphorus as polyphosphate granules within their cells. So this is also one process, but generally this is preferred. Okay, there are advanced techniques also, but these are generally not used in every normal treatment plant. Maybe developed country are using. In India I don't know where they are using, that is membrane filtration. Membrane filtration technology such as microfiltration or ultrafiltration can effectively remove remaining particles, bacteria and some nutrients. Reverse osmosis is there, but again this is not economical viable option to treat this much amount of water via this membrane filtration. Or the main problem is of choking. So what happened that both places we are using some kind of membrane, and as this much amount of water is coming, so this membrane get choked very easily. So you have to replace, yeah, regenerate these membranes very frequently. So people generally we don't want that thing. Okay, this technique can be used for advanced nutrient removal, achieving very low concentration of nitrogen and phosphorus, making water suitable for reuse in sensitive application. Okay, now. So this was all about tertiary treatment. This is by nitrification, denitrification, chemical precipitation, biological uptake, or some advanced technique. So coming to the second problem that related to this, so related to previous problem only which we have discussed. So just try to solve this question. So this is a simple question only related to what I have discussed in previous in last slides. So just take take your time. It's uh, just I am briefing what is the question that a wastewater treatment plant remove an effluent flow of this much water, this much meter cube of water per day coming with a total nitrogen concentration. So initial concentration and initial phosphorus concentration is there. Okay, now. So the plants aim to achieve the nitrogen removal efficiency of 85% and phosphorus removal efficiency of 90%. So now see this efficiency are achieved by are set by authorities. Okay, now so now suppose the wastewater which is there and their purpose is to suppose release the treated wastewater in a canal which will be used for irrigational purpose. The water treated water will be used for some kind of land, and they are saying that the maximum phosphorus that this land needs is around 2 milligram per liter. Okay, now so it should be ensured that the water which is coming should have only 2 milligram per liter of phosphorus. And we have already done some analysis, and we have already know that say here it is saying that 12 milligram per liter of nitrogen phosphorus is present, and here only 2. So from 10 to 2, this much should be removed. So you can see that how what should be the efficiency, that is 10 divided by 12 into 100, this much efficiency should be there. So it is around how much it will be, 3 around 90%. You can just calculate. So this much efficiency should be there. So you should just visualize the problem. Additionally, the plant is designed to have a denitrification bacteria with a retention time of 5 hours. So it is also saying that all this treatment process should occur within 5 hours. It should not take more than 5 hours. Okay, calculate the total daily load of nitrogen and phosphorus entering the plant. So now how much nitrogen and phosphorus is being entering in the plant, the required volume of the denitrification reactor, what should be the volume of reactor, so that only this much that can handle this much of water for 5 hours. The calculate the total cost of ferric chloride. Now it's saying that for removal of phosphorus, this ferric chloride is used because this nitrogen will be removed by some other process. If it costs Rs 6 per kg and is needed at the rate of 700 kg per day. Okay, now so per day this much kg of nitrogen is required, and per kg the price is Rs 60. So what will be the total cost of FeCl3? So anyone want to solve it? Yeah, I should just share the solution. You are open to ask anything in chat box if you have any kind of doubt. We are very small group. That is only three people are there, so anyone can ask any question. Just not related to this topic. If you want to you want me to discuss some topic of which has been already discussed, then I can also discuss that. Condition apply that I know that. Okay, so I will be moving forward with solution of this question. Okay, so you can see that first we have to calculate the a total daily total daily load of nitrogen. So influent nitrogen is uh, this much nitrogen is coming to our system. Okay na. So that is 100. Those who though the one who has joined right now, we are just discussing one problem related to wastewater nitrogen removal, that this much nitrogen is coming, this much nitrogen is going, this much is efficiency. We have to calculate the volume and how much ferric chloride has to be added. Okay now. So calculate the daily load of nitrogen. So first, so this much nitrogen was coming, that is 100 milligram per liter of nitrogen is coming into the system. Okay, and the flow rate is already given, that is this much we know that 1 meter cube is equal to 10, 1 meter is equal to 10 to the power 3 liter. Okay now, 10 to the power 3 liter. So we have multiplied by 10 to the power, so this much liter is coming. So total nitrogen is coming this much into this much. So this much kg per day of nitrogen is coming. Okay, the total nitrogen of similarly phosphorus, this much phosphorus is coming, that is 360 kg per day. And you can see it's already given that nitrogen removal efficiency is 85% only. So the total nitrogen which will be removed is equal to this much kg into 85, 0.85, that is 2250 kg per day. So this much nitrogen was coming, out of which this much nitrogen has been removed. Remaining will be released back, released in the maybe in river, or uh, maybe in lake, and or maybe in for agriculture purpose. Okay, then similarly the total phosphorus remove has efficiency of 90%. So this much nitrogen was coming, out of which this much was removed. So so remaining, that is this much, that is 36 kg of phosphorus will be released into maybe in river and all these thing. So this was all the loading. So second part was to calculate the required volume of denitrifying bacteria. So it is already said that retention time is 5 hours. So that is 5 hours means 5 by 24 days. And we know that the flow rate is this much. So what is my aim, that for 5 hours this much volume should be handled by our reactor. So we can always calculate the volume of the reactor is equal to flow rate into retention time. The flow rate is this much meter cube per day, and the retention time is 5 by 24 day. So this much big should be our reactor. Okay, I hope this is okay to you. Okay, the cost of ferric chloride, that is Rs 60 per kg is there. Okay na, Rs 60 per kg is there. So uh, miss, remember this 60 per kg, miss, if you have miss, those who have not seen my previous question, like that how this has been defined, that this much per kg of ferric chloride is needed. So this can be uh, I will go miss see, this is another problem. Okay na, like another problem can be also form, like how much kg per day of ferric chloride is needed. So this is another problem. Remember, I have already given you this data, that this much of ferric chloride, but another question can be added in this problem, that calculate how much ferric chloride should be needed for removal of this much of phosphorus. So in this question already they have given you 700 kg per day of phosphorus is needed. Okay na, this ferric chloride is needed, but in itself it is a problem. Miss you, this is not a specific thing. You have to calculate based on the amount of removal and all these things. So total it was, that's why I said that it's very simple question. So so total cost per day is this much, and the total cost per month can be this. So this was just simple multiply the question. The real question could be this thing. You see, in this question I have asked to calculate the amount of aluminum sulfate required. Okay na. So and in this question was also easy, that see this much water is coming, this much phosphorus is coming, and after After discharge we have 1 milligram of phosphorus. So they are asking that how much aluminum sulfate has to be added, given that 1 mole of aluminum precipitate 1 mole of phosphate. Okay na. So this question, so similar to that, if another question was that to remove, to achieve 90, and remember this ferric chloride will be only used for removal of phosphorus. See, if you have any kind of doubt, you can ask. If you are not able to understand anything, just tell me. Okay, na? So another question can be there that in that question that we know that for 90% efficiency was of phosphorus. Okay, na? So a question could should be there that how much ferric chloride has to be added. Okay, na? And now that see in this question it is already given that 1 mole of aluminum precipitate 1 mole of phosphate. So if this question, this statement was not written, then one should have, what should have done that they should write the reaction between aluminum sulfate Al2SO4 whole thrice, and we know that the phosphorus will be in the present in form of phosphate PO4 3 minus. Okay na. So and one will write this equation, and we know that this will form aluminum phosphate LPO4. Okay na. So LPO4. So here we will do this balance equation balance, and from that we will be finding that how much phosphorus is being removed by addition of 1 mole of. Similarly, in that question, instead of giving that this much ferric chloride is being added, a question could be that how much chloride should be added. So again here what could have been done that this instead of this Al2SO4, the equation will be FeCl3. I hope you understood what I am trying to say. Did you get it what I am trying to say? So this question was simple, that this much is coming, this much is coming. From here we calculated the mole, and the mole of sulfate will be equal to the mole of this phosphorus removed, and we know the molecular weight of aluminum sulfate, so we find out this much kg per day of aluminum sulfate is required. Similar question can be framed for this thing also. That is this ferric chloride also. Then again you have to write equation, and by a stoichiometry you can find out that how much chloride has to be added. Coming to this adsorption and ion exchange, we know that for adsorption, suppose we have some heavy metals like arsenic is there. Suppose in your wastewater arsenic is there, or maybe some chromium is there, or fluoride is there, and anything can be there. So and if you want to remove that heavy metal, so different process are there, chemical use of chemicals, that I will also discuss. But first here we discuss what is this adsorption and ion exchange. So tertiary process such as adsorption and ion exchange are essential in final stage of wastewater, focusing on removal of residual contaminant, heavy metal, and specific ions from the treated water. Okay now, heavy metals means chromium and all these things. Specific ions, maybe we want to remove, suppose we have a high amount of calcium, and we know, and suppose our target is that we want to reuse for drinking purpose, and we know that in is code it is written that the maximum calcium should be around 100 milligram per liter. I have to see, it is 100 milligram per liter. Okay na. No, sorry, not 100, 1000 milligram per liter should be calcium. 1000. Just 1 minute. Just 1 minute. Don't. How much calcium should be there? So you can see that calcium should be, sorry, only 200. 200 not more than 200 milligram of calcium should be in your water. And now suppose if your treated water has a calcium of maybe 1000 milligram of per liter, 1000 milligram per liter, so it has to be removed. So general method can be use of some chemicals or use of this uh, uh, some kind of adsorbent. The definition of adsorption is adsorption is process where contaminant adhered or attached to the surface of solid material that is known as adsorbent from a liquid phase. Okay, na. This method is particularly effective for removing organic compound, heavy metal, and dyes. Now, suppose some heavy metal, say arsenic is there. Arsenic is arsenic. Suppose what will happen that we will have one chamber. Generally, this method is not. Achieved. I hope you miss. Suppose any heavy metal is there, say, and its concentration is very high. So, and we know that this element can be removed by that's some solid. So we will put that solid in that chamber. We will apply the water, and what will happen that all the contaminants which will there will be get absorbed here, and we finally will be have contaminant free water. Okay, the common adsorption are activated carbon, highly porous material that effectively removes a wide range of organic compounds and some inorganic substances. Okay. Then we have zeolites, natural or synthetic minerals that can absorb cation and some organic molecules. Then we have biochar, a carbon-rich material that produced from biochar, effective in absorbing various pollutants. So these are miss you should you I think you have understood what is adsorption. So if you want to know more about adsorption, so I am referring you one book. Please go through that book. It's see, adsorption in itself is a very big topic. Okay, na. So if I start teaching, if I start explaining adsorption, it will take. So there is this book, Water Chemistry by Benjamin. Chapter number 10 deals with adsorption. Chapter number 10, chemistry, not 10, adsorption process. Chapter number 13. Okay, na. So page number 769. So see, this chapter is adsorption reaction. So this chapter deals like, if you are interested in environmental engineering, I will request you to go through this book. They will explain, they have explained what is the real life application of this adsorption. They have given some examples how people are using for removal of which kind of elements, which kind of I hope you are getting. And they have also focused on mechanism, the mathematical part. So here you can see this for removal of chromium. Some there is some example. Okay, na. So you can see similarly remove. They are different thing. Okay, na. So take a screenshot of this book. You can find it easily. Just search on internet Water Chemistry by Mark M. Benjamin. Did you get it? What I was trying to say? Those who are available. How many people are there? Four people. Only four. Sumna Mati. Sumna.
Yes, sir.
And there is another person. If you, okay, just go through this book. It has explained. And if you are interested in this water in wastewater water chemistry, so this book is really good book. In our college in IIT, most of the professor, those who teach water means geochemistry of water, like pH, means pH, you can anything about this water parameter, we follow this book only. You can see they have started with basic what aquatic chemistry, then chemical reactivity, reaction, potential energy, acid base. Just go through it for more knowledge. Okay. And if you are interested, there are several books. If you are miss if you there are several books, one another. If you are just interested in organic chemistry, suppose if anyone is interested in removal of organic thing, then for that we have this book. Generally people prefer this book. environmental organic chemistry by this writer. I'm not able to pronounce, and there are many. So coming back to the topic, hmm. So this was our so this key principle are there. So I have just summarized everything about adsorption, but remember this is very big topic. Adsorption in itself is a very big topic. So I think for that you should go through that book. So adsorption isotherm, there are several process, several mechanism that is something describe how pollutant interact with adsorption that can be language or friendly. Factor effective adsorption, these are some common things that pH, temperature, contact time, initial concentration of contaminant influence the efficiency of adsorption process. Now, second process is like ion exchange. Ion exchange is irreversible chemical reaction where unwanted ions in water are exchanged for more desirable ones. This method is particularly effective for softening water and removing heavy metals. And generally, I again said for calcium, means softening means from hard water to soft water. Hard water, what we have hard water. Hard water is due to presence of calcium and magnesium, and we want to keep that within 200 milligram per liter. Magnesium, again there is some limit for magnesium also. Then if it is that, we will be using this ion exchange method. Okay now. So first, there can be this cation exchange resins. So cation exchange resins exchange positively charged ion. Examples: calcium and magnesium with hydrogen and sodium. Okay now. So what will happen that generally this kind of arrangement is there. This kind of arrangement is there. Oh, sorry. Hmm. So this kind of arrangement is there. We will be having the, sorry for the rough diagram. I am drawing on laptop only. Okay na. So this is extra line. Okay na. So now what will happen that we will fill the resins here. We will fill the resins here. It will be filled hard water or water containing high calcium will be passed, and it suppose it contains sodium. Generally geolites are there, geolites which is rich in sodium. So it will be containing Na plus. Okay na. And so what will happen that for each mole of so what will happen that the calcium will be get entrapped here, and there will be some release of sodium, and we know that sodium is not generally there is not what no parameters defined for sodium. So and the concentration of sodium is a little bit high also, then it will be okay only. So water will pass, which will be soft water free of any calcium or magnesium. Okay na. Then similarly we have this exchange negatively charged ion. Example: sulfate and nitrates. Generally we don't want any sulfate or nitrates in our water. And once OH is removed, this OH is a part of water only. So similarly this mechanism is followed. Okay na. Then the key principle are this ability of the resin to hold and exchange ions, which depends upon the ion property. And there are several resin. One of the resin is this geolite only, Zoelit. Just search on, you will see more what is this. Then we have regeneration. So what happen that we can regenerate once. What will happen that if keep using all the pores which is there will get entrapped with calcium. So there are some mechanism by which we can remove that calcium by passing fresh water from here, and we will have a calcium again. This can be reused for another batch. So used ion exchange resin can be regenerated by passing them with a concentrated solution of exchanged ion, restoring their exchanging capacity. Then uh, finally we have membrane process. All of you know about this membrane process. one of the most this most it is very not commonly used because this is very expensive method. Okay na? So not to all people uses, not all treatment plant use this process, but still some of the developed country in India, some part uses this membrane process. Membrane process are advanced tertiary treatment used in wastewater to separate contaminants for water using semi-permeable membranes. So you know that there will be membrane and water will be passed through here. The contaminant will get attached to here, and we will have a contaminant free. Okay, now the process are effective in producing high quality effluent suitable for reuse or safe discharge into the environment. Okay, the type of membrane are there are microfilters that has a diameter pore size of 0.1 to 100 micrometers. Micro, you can see micro, micro, very small. Micro means 10 ki power minus 6 meter. Remove suspended solids, bacteria, and some viruses. Common use pre-treatment before reverse osmosis or final polishing step. Then we have ultrafiltration, that is nano filters, that is 10 ki power minus 9. This much is 10 ki power minus 6. This one is 10 ki power minus 9. Okay, now removes larger organic molecules, colloids, and some viruses. Used in water reclamation and wastewater treatment for separation of suspended solid and micromolecules. Okay, we have nano filtration. Again same thing, depending upon the type of, suppose see, once the treatment has happened, we do some kind of analysis. Okay na, and after analysis we identify that which kind of contaminant is there. Depending upon the type of contaminant, we generally use that kind of filter. Okay na, so either we can use this nano filter, reverse osmosis. Okay na, so I'm not going through this, but I hope you have got the idea what I'm trying to say. So less than one nano, see, and key advantage of membrane process are high separation efficiency. Membranes can be achieve high removal rates for variety of contaminants. See, the one of the reason why this is costly, because see, you have to make a membranes of this much size. This a small size, pore size should be this small, so that ions, when water is passing through it, ions can get entrapped on these these membranes, and making those pores of this much precise size is very costly, require advanced technology. That's why this process is very costly. Compact design, membrane system requires less space. Obviously the it will be a it will require very less space. Flexibility, membrane process can be adapted for various applications including wastewater use and distance. Low cost, low chemical requirement, generally no chemicals are required. Okay, so I have two questions related to previous things. So okay now, so just a simple question is there. So a water treatment plant is designed to treat this much meter cube of effluent using ultrafiltration. Okay now, followed by reverse osmosis. So first there will be ultrafiltration, then there will be reverse osmosis. Okay. The effluent characterized before treatment are follow. Suspended solid before treatment, suspended solid was this milligram per liter and TDS was 1200 milligram per liter. So see, this much of suspended solid was there and this much of TDS was there. So can anyone tell the for our drinking purpose? Suppose again I am using ultrafiltration and reverse osmosis. One should understand that our target is to make the water suitable for drinking purpose. So can anyone tell what is the permissible limit of TDS in our drinking water? Anyone? Some, so I don't know why I say lift. So here you can see what is the permissible limit of TDS. This TDS should be this. See, this is permissible limit. Means if in absence of any kind of treatment process and all this thing, and we have this required limit. required limit. Okay na. So this much is required, like minimum 500 should be there in our system. Okay na. So generally this limit is generally, if some salesperson reach your home and say that that I'm not going to explain that this thing, but this is our target. Okay na. So here you can see again our question was this thing that where did it go? Huh? That this TDS is not suitable for drinking purpose. Obviously, if you are investing this much, so this much can be drink. See, drinking this much of water is not a problem, but that is not recommended. That is only recommended if you don't have any treatment plant. But you are spending this much of money still drinking water having TDS of this much is not good. Generally, it should be around 500. Okay, na. So generally it should be around 500. 500. So and suspended solid should be no, there should not be any suspended solid in our system. So we have two problem, that calculate the total suspended and TDS entering the treatment lemma. This is very simple question. If ultrafiltration process is to design remove 90% of the suspended solid, and the reverse osmosis is designed to remove 99% of TDS, calculate the effluent quality after each treatment step. Okay na. So so you have to see the uh, just try to this is very simple question. Just you have to the initial value and the final value. Only thing you have to know that first there will be ultrafiltration followed by reverse osmosis. Okay na. So this much of water coming, and you have to tell that what is the final, the water which is coming after end of the treatment plant, how much TDS and how much suspended solid is there. If the efficiency is 90% and 99%. Okay. So I will be going through one by one. So you can see that first part is very simple, that to calculate the total suspended solid and TDS. This much this much water is coming, that is 50,000 meter cube per day of water is coming, and in the liter it will be this much. So total suspended solid will be concentration into flow rate, and we know that TCS, that is total suspended solid, is 150 milligram per liter. It is saying that 150 milligram per liter. So it will be 7500 kg per day. Similarly, TDS will be 60,000 kg per day. Okay na. Huh. So the effluent now after ultrafiltration suspended removal is 90%. In we know that in ultrafiltration the suspended the efficiency is 90%. So that is so whatever is coming into our system will multiply by zero point 0.9, then this much is removed. Remaining TSS how much is going into the for reverse osmosis, that is 750 kg per day. All the remaining has been removed. Now after the effluent TSS, that is the total suspended after ultrafiltration will be this much, means this much is being removed, this much is going for the next section. So that is 50 milligram per liter TSS is going in the next unit, that is reverse osmosis. Okay. hmm. Similarly, the TDS remove TDS. Hmm. I think I made one mistake here. So effluent quantity after reverse osmosis is remove TDS is this much kg per day. So you can see that initially the suspended solid was this much kg per day. After treatment, it is 15 milligram per liter. Similarly for TDS, this much was coming. 99% was efficiency, so this much will be removed. So remaining will be this much kg per day, that is 600 kg per day. And we know the flow, so we will multiplying dividing by the flow, and we will be knowing the concentration, that is 12 milligram per liter. So here in the question it is already written that ultra filtration process is designed to remove 90% of suspended solid, and the reverse osmosis is designed to remove 99% TDS. Okay now, so it is not working combinedly, so these are different process. Okay now, so when ultrafiltration is not able to remove any kind of dissolved solid, and similarly this RO is not able to remove, we are assuming that thing. Okay. Huh. So effluent TDS, so this was again a simple question. Sorry, any doubt in this thing? I hope all these are clear to you. Coming to the last topic, that is disinfection and chemical treatment in wastewater. So again, I have shown you this thing. What is I have discussed this thing, disinfection, that some pathogens are there and we have to kill those pathogens because they can easily, those are responsible for, waterborne disease. Okay na. So so and chemical treatments again for removal of heavy metals, yeah, any harmful, yeah, harmful pollutants, chemical treatments are there. We have already seen two examples that for suppose not that was for nutrient removal. Suppose in our generally, suppose see, I am generally giving the, if you have attended my previous lectures, I have always given you the example of chromium. Because in the wastewater treatment plant which I have visited in Kanpur is the wastewater has high amount of chromium, and in our lab also we are working on removal of chromium treatment. So I have some idea about how this chromium is being removed. So generally, for removal of chromium, generally we use one salt, that is iron salt, that is FeSO4, that is Fe2. And see, chromium can be in the two form, that is chromium 3 and chromium 6. Chromium 6 is not that much toxic. It is toxic, but that is not that much harmful as compared to chromium 6. But on another hand, chromium 6 is very carcinogenic, that is it can cause cancer and it is very toxic. So what will happen, that if there is some water, and if the chromium 6 is present in that water, then that water will turn yellow, yeah, greenish color. Okay, it will be greenish yellow. Okay now, if I have time at the end of the session, I can show you how this chromium contaminated water, if you chromium contaminated water occur. Okay now, so there is one village here, Khanchandpur. So what happened, that we have worked there. So if you pump water from that, from any borewell, yeah, any hand pump, the water which is coming is green in color. So this much high amount of chromium is there. Okay now, so what we have suggested some mechanism also, that collect that water in bucket, add some iron to salt. So what will happen, that this chromium 6 will get converted into chromium 3, and this iron will get converted into iron 3, iron 2 will get converted into iron 3, and these will form one kind of precipitate. And this precipitate can be removed, and we will have one chromium free water. Okay, I hope you are getting it, what I'm saying. And again, so this was all about chemical treatment. Then disinfection, we have already seen that use of chlorine or ozone and all these things. So I will just go through it one by one. Are crucial step in wastewater treatment that aim to eliminate pathogens, microorganism, and reduce harmful pollutant like chromium, arsenic, fluoride. Fluoride is also there. Ensuring that treated effluent is safe for discharge or reuse. The process helps improve water quality and protect public health and the environment. So this chlorine is there, processed chlorine or chlorine compounds like sodium hypochlorite are added to water to kill bacteria, viruses and protozoa. Okay, now so these are harmful pathogens that can cause harmful disease or waterborne disease. So by adding it, we can kill those, and water will be fit for drinking. Advantage: effective against broad range of pathogens. Residual chlorine can provide ongoing infection in distribution system. Now suppose if this is your treatment plant, and suppose after treating नहीं if you want to transfer this water to, suppose if I had been treated at such a level that we want to reuse for drinking purpose, so obviously it has to be passed, it will be passed via some kind of pipeline. So there are high chances that in between some pathogens might enter. So to prevent any further contaminant by pathogens, we add some extra amount of chlorine, that is known as residual chlorine. Okay, now that will make sure that if some contaminant or pathogens are entering in our wastewater, that can be killed immediately. Okay. Disadvantage there: formation of harmful bioproducts and potential environment. So there are some kind of harmful, sometime harmful bioproducts are formed. So just if sometime if I have time at the end of the lecture, I will explain why. So this is very interesting research topic. Okay, na interesting research topic. This disadvantage the bioproducts which are formed during chlorination. Okay, so I will explain at the end of the session. Then we have this UV rays, which is very costly. That's why generally these are not used. UV are too inactive macroorganism by damaging their DNA. No chemical residue effective against wide range of pathogens and minimum environmental impact. Requires regular water for effective treatment, and no residual protection. Means once the water has passed through the treatment, and suppose after few hours, suppose some contaminants has entered, so this method, this there won't be any use of this ultraviolet, because you have to, so that's why it is costly. Then we have this ozone is generated on site, introduced in water to oxidize and inactive pathogens. Powerful oxidant, effective against wide range of microorganisms, require a specialized equipment and treating this. So you can see that these are just for, miss, if you are using water on a spot, suppose after treatment, suppose if you kept your water for longer time, again there will be some contaminant, and this UV and ozone will not make sure that of any future prevention of any contaminant. Then we have heat treatment. So this is like this we all know that we generally people suggest that we should drink water after heating and all these things. This is just to make sure that all pathogens are killed at high temperature. Then we have chemical treatment. I'm not going to discuss it. I have already discussed some chemicals are added, then that can be precipitated. We have also solved two questions related to this aluminum sulfate and ferric chloride, and I have given you some example of this thing, chromium, how chromium is being removed. pH adjustment, precipitation, same thing, that by adding some salt, we are pH adjustment, by adding some acid we will remove something. Okay, now so from next onward slides, there are some questions which can you can expect in your this thing, you can expect in your assessment, or if you are preparing for your end exam. So I will be going by one, and I ask you to please participate it and try to answer it in the chat box. And before discussing, if you have any kind of doubt, you can unmute yourself and you can ask, or you can also write in chat box. Need any kind of reference of any book, or anything to understand any topic? Anyone? If not, then try to answer this question. The advanced treatment. advanced or tertiary treatment of water is used to remove? One answer we have received B. I request other also to participate. There are four participants, so just try to answer it. The advanced or tertiary treatment of wastewater is used to remove what? A option, B option, C option. So see, the suspended solids, they are typically removed during primary and secondary treatment. We have seen this thing. In primary treatment, we add some coagulant, flocculant, then we have sedimentation tank and all these things. So on that, by that process, the suspended solids are removed. Primary treatment uses physical process like sedimentation to remove larger solids, while secondary treatment focus on biological process to further reduce organic material and suspended solids. Then we have this yes, be the correct answer that this advanced treatment is used to remove pathogens and emerging contaminants. Okay, na. So this treatment targets the specific compound nutrients like nitrogen and phosphorus can be cause because we why we want to remove, because it can cause eutrophication in water bodies while pathogens poses health risk. Emerging contaminants include this we have already discussed. Sediment, while increase, these are typically addressed in primary, and again these are removed in primary and sedimentation. While increase is removed in preliminary treatment only, but some may pass into this primary tank, and there also they are being removed. Okay, na. So yes, the correct answer is B, nutrient, pathogen and emerging contaminant. So now we were talking about this emerging pollutant. So which of the following are the emerging pollutant in wastewater? A, PPCP. So these are generally medical waste. Okay, na. Then we have nutrients, then we have organic matter. Okay, so the ppc, they are considered emerging pollutant because they are frequently detected in wastewater, because now this and are not typically removed by conventional wastewater process. They include substances like antibiotic, hormones. So now what happened that these people are using too much medicine and all these things, so somehow they are being released in our wastewater. So even in a small quantity they are causing some effect, and our conventional method are not designed to remove these contaminants. Okay, now, so for that we need advanced treatment. So yes, correct answer is A. Okay, so we have already discussed this. Uh, mm, uh, these are not means these are all means not emerging. These are from old age only, from long time. This nutrients removal, organic matter, and all these things. So the correct answer is A, PPCP. Try to this match the following process for slash treatment given in the first column with their specific objective given in the second column. So first we have chemical precipitation, a co-precipitation, then we have ammox process, then we have chlorination process. So all three things we have discussed in great details. So try to answer it. Precipitation, then ammox process, then chlorination. We have answered D. First is A, C. Yes, D is the correct answer. Yes, D is the correct answer. So you can see chemical pressure. We have already seen that we can add some chemical to remove these dissolved metals such as chromium, sodium, calcium, and all these things. Okay, now then ammox process. This is biological nitrogen removal process that specifically targets the conversion of ammonia and nitrate into nitrogen gas, thus removing the nitrogen from the wastewater. And finally, we have chlorination. Is commonly used for disinfecting wastewater to kill pathogens and make sure for discharge and reuse. So you see, ACB was our D option. Is correct answer is D. Coming to the fourth question, activated carbon-based adsorption units are regarded as effective for removal of this thing. I have also discussed activated carbon-based adsorption. So to answer this question, you can also go through how these microbial contaminants are removed, how these nutrients are removed, how alkalinity are removed, how pesticide are removed. Just try to answer that. So you will are you this Suhas, you are giving answer of this question or previous question? D. Okay. So this was very also simple question. This we know that this for microbial contaminants we use chlorination. For this nutrient we use this we remove we use either some kind of nutrients can be in the form of nitrogen or phosphorus. So for removal of nitrogen we use nitrification and denitrification process, and for removal of phosphorus we can use some kind of chemical like aluminum sulfate or ferric chloride. Similarly, for alkalinity and hardness we do this ion exchange process. And finally, pesticides are removed via activated carbon, because these pesticides are getting adsorbed on the surface of carbon, this activated carbon pesticide. So this uh, see another thing. See, hmm, while activated carbon can provide some reduction in microbial due to surface, it's not primary design. See, because we know that this microbial remember in the process of treatment, it's all about efficiency. If you read any research article, and if you any read about anything, remove treatment process by some such and such mechanism, you will see that it can remove. So that's why I have written here that can provide some reduction, but it's about efficiency. Can it remove that particular contaminant in efficient way? No. So that's why it can remove some microbial contaminant, but it won't be highly effective, because we know that for again this is not property of anti activated carbon to remove microbial thing. So that's why other method like chlorination and filter at generally chlorination is choose. Okay na. Similarly, nutrients, particularly nitrogen phosphorus, require a special biological process or chemical treatment rather than adsorption or alkalinity. These are used in organic compound, like these are not covered by activated carbon. Okay na. So here we have seen this ion exchange softening process and all this thing. So, but SC is highly effective at absorbing organic pollutants, including pesticide from water. Its large surface area and porous structure allow it to trap this contaminant effectively. Okay, so the correct answer is 4. First step of adsorption mechanism majorly involves the process of. So I have not discussed this thing, how mechanism of adsorption. So but you can just, I have said you one thing that there will be some solid will be there, and dissolved ions which is there will get attached to this surface, and this process in order adsorption. But there should be some mechanism na sir, how this transfer happen and all this thing. So for this question, miss, if you are not able to answer again, but I have got answer, mass transfer to the is good, but you can look into the great detail in the book which I have suggested you. So the mass transfer, this is the initial step in the adsorption mechanism. It involves the movement of solute molecules, that is dissolved ions, which is there. Okay, now from bulk solution to the surface of the, so this is our adsorption. This is our surface. Particles are here and there, everywhere is there. So what will happen that so the molecule will move from here to the surface of this adsorbent. Okay, the effective mass transfer is crucial for ensuring that contaminants reach the adsorbent where they can be removed. So what happened that we will be will be we will be making sure that all the contaminants are passing through the adsorbent. So that's why the first step is the mass transfer. The second is diffusion. Now once suppose this was our layer, once it has come in the contact of adsorbent surface, the second step will be diffusion into adsorption process. After mass transfer, if the adsorbent molecule are not immediately absorbed, they may diffuse into the pores of, so obviously there will be some pores here. So what will happen that get it will diffuse in the ports of adsorption. This step is essential for larger adsorption, but not the first step. Okay. Then pore surface adsorption. This occurs after adsorption had diffused to the surface or into the pores of the adsorption. So obviously again, if some adsorption has happened in the pores, so that will be the third. So it involves the actual bonding of the adsorbent to the adsorbent phase surface adsorbate to the adsorbate. So finally, what will happen that there will be a proper bonding, and the particle concerned particle will get removed. There is no point of talking this point. So again, we have first, the answer was A option, that is mass transfer to the adsorbent surface. Coming to the sixth question, the most preferred flow and regeneration pattern for typical ion exchange. So again, I have explained via this example. Try to answer this question. What will be the preferred flow? This is, remember, this is downward and this is upward. Any answer? Hmm. So downward flow in normal service run, this configuration is standard for ion exchange system, and it maximizes the contact time between the influent water and the resin, allowing for effective removal. So what will happen? The downward flowing resins will be here, water will be coming here, and it will be slowing passing. So there will be a proper interaction. Okay, na. Reverse flow generation, during regeneration the flow direction in reverse. Now what will happen that once the party, suppose this was our region, this was our region. Here we have our region. Okay, na, everywhere is region. Now what will happen that once the particle is getting attached, so it has been attached here. So now what will happen that, now suppose if I, for regeneration process, what will happen that we will be passing water in the back direction. So those which has get attached can just can peel off from the surface of the adsorbent regions, and it can go to another system, and so that we can again pass again this resin will be used for uh, reuse for another batch treatment. Okay, na. So it helps them minimize the challenging and ensure more informed distribution of reagent regeneration. Okay, the combination improves the efficiency and effectiveness in ion removal and regeneration compared to the other option. The most preferred flow and regeneration pattern for typical ion exchange is C. Downward flow in normal service, and reverse flow regeneration. The correct answer for this question was C. I hope you have understood this. This again, this is a very simple reaction, and must, if you have gone through the lectures, this reaction is this reaction represents, what does this reaction represents? Phosphate removal. This cannot be answer because there is no phosphate. Does it nitrification? So first, one should know that what happened in nitrification. Which form of nitrogen is changing into which form of nitrogen? Similarly, we have denitrification. There can be nitrification reaction. Okay, you are saying nitrification reaction. Again, we have denitrification reaction. We know that in denitrification, final step is there will be N2 will be released. So, and then we have amox reaction. So I will just go through where I have discussed this nitrification and all. Hmm. You can see in nitrification following thing happen, that ammonia is getting converted into nitrate. Okay na. First ammonia is getting converted to nitrite, and nitrite is getting converted into nitrate. And finally, in this denitrification, what will happen, that this nitrate which has formed from nitrification is finally getting converted into nitrogen gas. So neither we have answer B, neither we have answer C. MOX reaction is conversion of ammonium which is present in water, to nitrogen is known as amox. Okay na. Amox reaction, so the correct answer will be D, not B, C. That is B won't be answer, I think. Remember, nitrification is um, conversion of this. You can see here, nitrification is two step where ammonia is first oxidized to nitrite NO3 by this AOB bacteria, that is ammonia oxidizing bacteria. Then nitrite is oxidized to nitrate NO3 by nitrite oxidizing bacteria, that is NOB. Okay na. Remember, we have particular name for that bacteria, that is this using nitrosomus and this nitrosomus. Okay na. And then finally nitrovector and all these things, nitrosomus and nitrovector. And finally in denitrification, we have pseudomonas. Hmm. uh, the correct answer is D. This process reduction of nitrite to nitrogen under aerobic condition. So, and here you can see they are using ammonium. Okay na. Ammonium and nitrate is getting converted into N2. This process involves anaerobic oxidation of ammonium NH4 plus with nitrite to produce nitrogen gas and water. This is crucial step in nitrogen cycling, particularly in wastewater treatment, where it contributes to nitrogen removal. Okay, so remember this. There is one nitrogen cycle. This I will show you what is this nitrogen cycle. There you can see in great detail, like nitrogen cycle. Here you can see like this nitrification and denitrification. The same concepts is being used in wastewater things. The final step is to produce nitrogen. So here you can see that we have nitrifying bacteria. First ammonium is getting converted into NO3. Then we have denitrification bacteria, that in NO3 is getting converted into N2. So there is in a step process also. This first NO, uh, in between there, something else will be formed. Some similarly this see, this is ammonification. We have ammonia in presence of NO2, and finally it is getting converted into NO2. Okay na. So Just read it. You can refer any standard book. Yeah, this is from Baiju, or you can just refer any standard book of what happened in wastewater. Okay, na. So you will come to know. I hope this is clear to you. Did you get it? Which of these are not used for disinfection of wastewater? Eh, this is very simple question. I am not. We know that this is used, this is used, this is used, but this is not used. Again, there will be a question. There might be question which is the most effective. Can anyone answer which is the most effective and economical? Economical also. Most effective is UV. Economical Cl2 gas या NaOCl. Most economical will be this NaOCl because this supplying into chlorine gas is very challenging task. We have to you cannot, but this come in the form of salt. Yeah, this come in the form of solution also, so you can directly add this solution in your water. Okay, na. So this ultra, we all know that for disinfection UV is huge. Okay, na. But this microfiltration is used to separate suspended solid and bacteria. We know that. While macrofiltration, so the our answer will be B, but you should know the region also. This method use ultraviolet light to disinfect water by inactivating microorganisms without the use of chemical. It is widely used in wastewater treatment. Microfiltration is a physical separation process used to remove suspended solid and remove bacteria from water. It is not primarily a disinfection method. It can help reduce. I hope you got it. Chlorine gas is the most common. Then this is commonly used. So this is generally commonly used. Remember. So this is most effective. This is also very effective and economically accepted. Generally, sodium hypochlorite are used. Okay, now. So correct for rubber, the correct answer is B. This is not used for disinfection. We have two statement. You have to identify which one is correct, which one is incorrect. Yeah, both are incorrect. Yeah, both are correct. Four option is there. RO is a process that uses advantage of natural osmosis flow to purify water in low pressure. First, you should know the concept of reverse osmosis. How reverse osmosis is done. Then only you can answer this question. RO can reject chemical polymers easily while it cannot remove monomers from the water. So, with some common, like to answer this question, if you know what is reverse osmosis now, like how reverse osmosis is done, anyone just easily answer this question. There is no rocket science in this question. Very easy question. Anyone with any answer? So both the statement are incorrect. Remember, for reverse osmosis, high huge pressure is required. Incorrect. Reverse osmosis reverse the natural osmosis process by applying a high pressure to force the water through the semi. So there will be a membrane. Water will be. Hmm, eh, so there is one process like miss I don't I just forget them. So just you can see the reverse osmosis, the natural process by applying a high pressure is required. So I will request you to go through the mechanism of reverse osmosis also. I won't be explaining the mechanism of reverse osmosis, but I request if you want to answer this question in great detail, just go through the mechanism of reverse osmosis. There are several YouTube videos. Just on YouTube search mechanism of reverse osmosis. Then you will see they will be explaining the membrane, water is here, no water is here, and all these things. Can RO membrane can reject both large molecule, that is polymers, and smaller molecules, monomers, depending upon the size, charge, and chemical properties of the contaminant. Typically, RO is effectively in removing wide range of contaminants, including dissolved salt, organic compound, and even monomers. Okay, na. So here it can remove anything. It is not that it can remove only remove this thing and not this thing. So it can remove all things. So both the statement are incorrect. So our correct answer was D. Both statements 1 and 2 are incorrect. Coming to the question number 10. Advanced oxidation process targets hydroxyl radical, that is OH hydroxyl, which is typically produced by. Again, this is simple, very simple question, and I have given you some context like what is this advanced uh, uh, oxidation process AOP. So this advanced oxidation process rely on generation of highly reactive hydroxyl radicals to oxidize and break down the contaminants in water. These radicals can be produced through various methods. For first is photochemical degradation process. UV light can be used to produce this radical from the photolysis of hydrogen peroxide, that is H2O2, or ozone, which are key component in photochemicals. So with the help of UV and this chemicals, that is H2O2, this OH minus can be produced. Okay. Then we have photocatalysis process. In photocatalysis, materials like titanium oxide are used to use a photocatalyst. When exposed to UV light, these catalysts generate these radicals. Okay. Then we have chemical oxidation process. Chemical process involving substance like ozone and hydrogen peroxide. Again, all these processes are used to produce this OH radicals. Okay. Uh, I think we have numerical question. So before going to, we have again uh, two simple question. Electrodialysis use the principle of attraction and repulsion by anode and cathode of opposite charges ions. B. Ion selective membrane to permeate the ions of a specific charge while rejecting the opposite charge ions. That is both A and B or neither A and B. I think D, we have got answer D. Neither way. So I will be going through this one by one. So electrodialysis is a water treatment process that involves the movement of ions through ion selective member under the influence of electric field. The principle involves both the attraction and repulsion by anode and cathode of opposite charge. When an electric field is applied, the positively charged ions are attracted to the negatively charged cathode, while the negatively charged ions are attracted to positively charged anode. This forms the base of ion separation. So I don't know why you said C. The correct answer will be D. Both. C. Both A and B. Both. In ion selective membranes to permeate the electrodialysis use two type of ion selective membranes. One allow only cations to pass through and another allow only ions to pass through. These membranes facilitate the separation of ion based on their charges. So both are correct. I don't know why you said you say any. If you want to discuss this thing, why you said C D, then we can discuss, or else I have explained why the answer will be C. Obviously, once see we know that in electrodialysis there are two two ends. One is anode and one is cathode. Okay, na. So what will happen once the electricity is applied? So the positive ions will be attracted to the negatively charged rod. Okay, and similarly, uh, the negatively charged ions will be attracted to positively charged rod, that is known as anode. Okay, so remember, ions are negatively charged and anode is positively charged rod. I hope this is clear to you. And similarly, now see we have membrane. In the middle we have membrane, and we have we have separate membrane for passing positively charged and separate thing for negatively charged. Okay, now which pre-treatment process may be used to control falling of the membranes? I don't want our membrane to start give any kind of a smell. So which pre-treatment may be used to control this? Yes, sir. Which pre-treatment process may be used to control fouling of the membranes? Membrane fouling is accumulation of unwanted substance on the surface or within the pores of the membrane, which reduces its efficiency. Several pre-treatment processes can help control fouling by removing particle microorganism and other fouling agent before the water reaches the membrane system. The first is filtration. Filtration removes suspended solid, particulate matter, and the large contaminant from the water which can otherwise clog the or fill the membrane. So chlorination is used to control biological fouling uh, by disinfecting the water and preventing the growth of bacteria and other microorganisms that can be biofilms on the. So B is also answer. Then UV irradiation is another disinfectant method that inactivates the microorganism in water, reducing the likelihood of biofouling, which can occur when biological material accumulates on the membrane. So yes, the correct answer is D. Coming to the numerical part, try to solve this question. If you have gone through, if you have see, if you have this is similar question which I was explaining the last time. Here just you have to make sure that this having this much same question is there. Okay, na same question is there. You can see. First, you have to find this total solid removal efficiency of UF in approximately how much percent. Removal efficiency in ultrafiltration of total solid. Uh, we have 15 minutes, so take your time. The two more numerical problems are there, and all those are very simple questions. So uh, I think I will show you the solution at the end of session. We can have some discussion. So we have given this data. The flow of the effluent from the secondary clarifier is 5 mld. TDS of the effluent is 2200 milligram per liter. The TSS is 30 milligram per liter. TDS after UF is 460 and TSS is 0. And the permeate produced by UF is 95% and concentrate produced by UF is 5%. This data is already given to us. Okay, now. So the initial solid concentration will be total this much plus this much, that is 2230 milligram per liter. So this much will be total solid. After ultrafiltration treatment is we have TSS reduced to 0 and TDS reduced to 460. Okay, na. So the final TS will be TS after US will be this much, that is 460 milligram per liter. So this was very easy. So the total, remember the question is about total solid. So that's why we are calculating total solid in first. The total solid removal efficiency will be given by initial TS minus final TS by initial TS into 100. So that will be this much, that is around 80%. Okay now. So the final answer is TS removal efficiency of ultrafiltration UF is approximately 80%. 80, around 79.37, that is you can say 80%. Okay, the concentration of suspended solid in reject from UF, whatever the concentration suspended solid that was rejected from ultrafiltration, what is its concentration. So again we have this data for UF is that 5 mld is coming, that is 50 million liter per day. 95% of the feed, 5% of the fee was reject. uh, TSS concentration in the feed is this much is coming, and finally 0 milligram per liter is going. Okay now. So total mass TSS flow rate means this means we can see that 5 mld, this much total suspended solid is coming 5000 mld means 10 ki power 6 liter. Million, this mld means million liter per day. So the 5 into 10 ki power 6 liter per day into 30 milligram per liter. This liter get cancelled out. Finally we have this much kg per day. Okay now. So it is saying that 5% is rejected. So 5% will be 5% into 5 mld. See, the flow is 5% of the flow. So 5% into 5 mld, that is this much liter per day is the flow rate of the reject, whatever is being rejected. Or okay now. So so the TSS concentration will be TSS loading, how much TSS is being loaded, this much kg per day is being loaded. Okay now, divided by whatever is the flow rate. So that is 6, that is 2500, sorry, 150 kg per day. This much liter per day, sorry, this much liter per day is is the flow. So the concentration will be finally 600 milligram per liter. I hope this is also clear to you. Final question is what is the percentage of treated water produced from RO unit in percentage. So we have this thing data that permeate flow rate is 95% of the original flow, and the RO permeate flow is 3.2 mld. Okay na. So RO feed is 4.6, the RO treats permeate from the UF. Okay na. So whatever the permeate, see, first we have ultrafiltration, then we have this, there was some reject flow. Okay na. Then the water was going through to RO filter. Okay na. And RO filter, the flow will be whatever the flow is coming out from this ultrafiltration will be going into this RO. So the flow, it is in question, it is saying that permeate whatever the flow is 95% of the original. Okay na. So 95% of the original is 5 mld into 0.95, so that is 4.75. And the water which is leaving from RO has a flow rate of 3.2 mld. Okay na. So the calculate to calculate the percentage of treated water from RO. So the percentage of will be RO permeate flow rate by RO feed flow rate. Okay na. So that, so we will be, so what, how much water was coming? Water is going, 3.2 is going out, and come how much coming? 4.75. So the percentage will be 67.37%, because they are just asking the percentage of treated water. Okay na. And how can we calculate the amount of water coming and going? With the help of flow, because volume is always constant. So the percentage will be 67.3%. So the correct answer will be 67.37. Okay. So we have already discussed all the problem, and we have also discussed some topics in very detail. If you have any kind of doubt, you can write in chat box, or you can just unmute yourself and you can ask. How much time we have left? I think 5 minutes are left. 10 minutes. We have 10 minutes. Anyone have any question? Yeah, or do you want me to discuss anything? Just you can write in chat box. Anyone? So if you are not, I was going through one thing that I will be explaining in the last. What is this thing? This chlorine. So generally, what happened that na? Suppose in your system bromide is there, okay na? Br. So what will happen that so this chlorination process is a very uh, there are something that how chlorination work. So the ammonium. I will just show you my lectures. Then you might understand. See, this is the reaction which is happening in chlorination. Okay, now. So whatever the uh, see this sodium means in the form of OCl minus the chlorine has been added. So what will happen that the ammonium which is present there, it will react with OCl and it will form this monochloroamines, dichloroamines and trichloroamines. And what will happen that and this will be killing our bacteria and all this thing. Now suppose in your system we have this bromide. Okay now. So what happened that if bromide is present, so what happened that instead of formation of those three uh, chloroamine या diamine, monoamine, monochloroamine, dimono, whatever was that. We will have this kind of thing, that is CCl3, CHCbr, CBr3, CHCl2, Br, CHClBr2. Okay, na. And also if haloacetic, and these are considered to be very carcinogenic in nature. Okay, na. So if you are drinking this thing, you will have cancer. So now the question, so and if you see the if you in India, if you see that is there any protocol to remove these this byproduct, so you won't find any article or any restriction on these bromide, these are known as this BDP. Okay, na, the full form is, I don't know. Disinfection byproduct. So you won't find any restriction on this DBP. Okay, na. So so still we are using chlorine, and now suppose there is no restriction. So now imagine there is one situation. So there was one question raised. What the question was, like suppose so the first question was, should we restrict this should we stop using chlorine for this disinfection, because it might cause cancer if bromide is there also in our water. So if then it was said that if we stop using chlorine, so there are high chances that people might die from cholera and all these things. Okay, now. So there was some risk assessment was done. So it was said that if we stopped using chlorination, then people might die from typhoid, yeah, miss not typhoid, miss waterborne disease like cholera within 1 year by drinking that water. But if people start drinking this kind of water containing this bromine and all this thing, it will take long. But this cancer thing, yes, yes, these residual keep reacting. So see, so what will happen that uh, see this kind of graph is drawn initially. What will happen that yes, the whatever the free residual is there, see, free fr is known as free residual. So this will keep it will be in the form of these chloroamine. Okay, now. So these chloroamine with time will keep reacting if some after treatment some bacteria. That's why chlorine is suggested to be best method for treatment, because it is protecting from future contamination also. Okay, na. Huh. The answer for your question is yes. They do, see, the big disadvantage of the use of ozone UV is that they do not leave behind any residual protection against recontamination of water in distribution system. Any more doubt? If no doubts are there, then we can end our session. Oh, thank you. Please, so I am ending the lecture session today. Please join next week also. We have, I think, three more sessions. So this is week 9, 11, 12, 10, 11, 12. Do join those lectures. And if you have any question, just make a note of those question, and I will be happy to help you. But make sure that please participate in the discussion part. Okay, so that's all for today. Good night.